angle measures and segment lengths. I think we only have one new term in this little lesson, and it is the term secant. A secant is a line that intersects a circle at 2 points. So let's see what that looks like. That would be one, wouldn't it? That would be a secant intersects a circle at 2 points. So let's say I labeled that point A and that point B. I could say that AB is a secant line. Or if it's a line, I don't have to say secant line, but I could also call AB a secant segment, which we know would also be a what? A chord, right? A chord. So that's a secant, and let's see what theorems we have related to that. The measure of an angle formed by two lines that intersect inside a circle, so two secants that intersect inside of a circle, is half the measure of the angle, so that angle 1 there, its measure is half the sum of the measures of the intercepted arcs. Okay? So what if the secants intersect outside the circle? Okay, well, we got 3 cases of that. Right here we got 2 secants, right? And you see their point of intersection is outside the circle. And right here we have a tangent and a secant still intersecting outside the circle. And right here we got 2 tangents, right? 2 tangents. But anyway, you're going to figure out the measure of that angle in all the same way for all 3 of these cases. When the intersection is outside the circle, the measure of the angle is going to be 1/2 the difference. 1/2 the difference of the 2 intercepted arcs. So let's see how that's going to play out when we start to solve problems. So in our example here, what is the value of each variable? Okay, the only variable we got here is W. What do we have? We're going to use theorem 12-14, the one just right up above, because our intersection of 2 tangents is outside the circle. So what do we know? We know that 70 degrees, the measure of that angle, is 1/2 the difference of the intercepted arcs. So W minus 110. Of course, you're always going to do the big arc minus the little arc. Okay, so I'm going to multiply both sides by 2. By 2. So I'll get 140 is W minus 110. So if I add the 110, that'll be 250. So W is going to be 250. That major arc there, which if we named it with large letter endpoint, well, that's actually not the name of the arc, W. I probably shouldn't call it W, but that piece we're referring to is 250 degrees, okay? Because 70, the angle there, is half the measure of the large arc minus the small arc. Okay, we got some more. Let's see. Well, once again, our intersection is outside the circle, so that we know Y is going to be 1/2 the difference of the intercepted arcs. So 110 minus 30. So that's 1/2 of 80. So that's going to be 40, right? The measure of that angle there is 40 degrees. Okay, now this time our 2 secants are chords. They're secant segments, but they're actually chords. Okay, they're intersecting inside the circle, so we have to use that first theorem from the day that says this angle here, 35, and of course that applies to both of these angles because they're vertical angles, right? So either one of those angles is 35 because they're congruent. So that angle's measure is going to be 1/2 the sum of the intercepted arcs. So I got x plus 30 here. Okay, multiply both sides by 2. 70 is x plus 30. So 70 minus 30 is going to equal x. So the measure of this arc right here is 40 degrees. It's pretty easy, right? Pretty easy. I think so. Okay, now, so that's it for angle measures. Now, let's do the segment lengths part. All right, we got a theorem here, and it's really got 3 little parts that we have to remember. Okay, so the first part says, looking at number 1 here, So I got these two segments that are intersecting inside the circle. Okay, they intersect, so, and we know how to find the measures of the angles because we just did that. How do we find the lengths of the segments? Well, I know that in this case with the intersection inside, I know that the two parts of the segments, the two parts of each segment multiplied together is going to equal the product of the other two parts of the other segment. Okay, that was a mouthful, but you'll see how it works in just a minute. Okay, now, if we have this situation here, situation number 2, where the intersection of the two segments is outside the circle, then look at what we have. We have W times X plus W, right here, equals Y plus Y plus Z. So really what I have here, guys, is this W here is the outside, right? The part that's outside the circle, and W plus X is the whole segment. Okay, and I got the same thing on this other side. The Y is the outside piece, and this stuff in parentheses here is the whole thing. Okay, so what you really have is the outside times the whole equals the outside times the whole, and I like to remember that just like this. Ow, ow, you find this painful? Well, think of it that way. Ow, ow, outside times the whole equals outside times the whole. Okay, now if one of our segments is a tangent, like this one right here in scenario 3, okay, look what we have. We have t squared equals, once again, the outside times the whole. The outside times the whole. You can still think of ow, ow when you have a tangent, because if I look at t squared, the outside is t and the whole is also t. So that's still outside times whole, right? It's just the outside and the whole equal the same thing. Okay, so for number 1, you just got to remember the two parts. The product of the two parts of one equals the product of the two parts of the other segment. And then for the other two cases, you just got to remember ow, ow. Okay, so let's do some problems. Let's see what we have here. Okay, the intersection is inside, so we know if we look at JN, okay, we have 10 times X. So I'm going to put 10 times X there, and I know it's the product equal to the product of the two parts of the other chord that it's intersected, so 8 times 5. So 10X equals 40, so X has to equal 4. Simple as that. Okay, how about the next one? Find the value of X. Okay, well this is an outside hole thing, right? So let's look at AC. AC, the outside is 12. The whole thing is X plus 12. And I know it equals the outside of AE, which is 15, times the whole thing, which is 15 plus 9, so that's 24. Okay? Distributive property, 12x plus 144 equals 15 times 24. What's 15 times 24? 360. I cheated and used my calculator. Okay, so 12x equals 360 minus 144, which is 216. So if I divide 12 into 216, I get 18. And that's what they asked me. What's the value of x? 18. Is that a diameter of the circle? Maybe, but I don't know that it is, right? Because I'm not shown the center of the circle, so I don't necessarily know that that part goes through the center of the circle. So don't be too presumptuous here. All right, let's see what we have next. I think just a couple more problems, and then that's pretty much it for this lesson. Ooh, and these are your practice problems. So I am not going to spoil the fun by doing these right here. You're going to pause, and you're going to work these, come back and check your answers. Alrighty, here are your practice problems. I circled the two circles in different colors just so I could talk about them. I set up my situation here, outside hole equals outside hole. So for the red circle, I've got the outside part here, which is 6, and this whole thing would be x plus 6. So that product is going to equal 10 squared, and then when you solve that, you get 32 thirds. And then I can see that the situation is the same for the green circle, so I know that y has to be 10. It's got to be the same as that other tangent over there. Okay, this one here, I don't know, I got some crazy numbers, so please do double check me and make sure you get the same thing. But what I finally concluded was, look here guys, if this diameter that I just drew in red, they told me that it bisects this arc. Okay, if it bisects that arc, then it bisects this chord, and therefore it is perpendicular to that chord. So I made myself a little right triangle here, and then I just used Pythagorean theorem. I got that this x, this length of x here, is the square root of 119, and then when I went and solved for y, I got such a strange answer. I went back and plugged them into my calculator and turned them into decimals. So please do check me on this and make sure that I got this one right. It just seems like a really strange answer. But anyway, after I used the Pythagorean theorem to figure out what x was, then I used our new theorem from today, where I'll show you the two segments I'm talking about. I'm talking about this one and this one. And so the two parts of the one that's the diameter, x times y, equals the two parts of the other one, which are each 5. So I got xy is 25, and you see that's where I went to over here. And so when I tried to solve it using radicals, because you know I radically love radicals, I got 25 over the square root of 119. Instead of rationalizing that, I figured, let's just turn this one into a decimal. So please let me know if you got the same thing I did or not. I'm interested to see if I got this one right. Okay, and finally, standing in front of this large fountain, and you're 9 feet from it, your distance from you to a point of tangency is 24. So this is another outside hole equals outside hole situation. And I just set up that equation, worked it, got 55 feet for the radius. Please let me know if you have any troubles or if you think there's an error here somewhere. And I believe we have one or two lessons left. I know for sure we have equations of circles in the coordinate plane, but keep working on those worksheets and we'll see you next time.